So we didn't finish this Friday, and that's fine. We'll go on and finish it today. Because this is the one before sine of 105 degrees is one of the ones that we looked at on Friday. Now, it came out to be quite the weird value, to say the least, because when we look at these half-angle formulas, so for cosine, well, okay, let's see if it'll let me write. Come on. Wow. So if we look at cosine of 105, we're really referring it back to the formula cosine of u over 2 is equal to plus or minus the square root of 1 plus cosine of u is the formula we're looking at. Now we know the angle is going to be positive or negative based off of where u over 2 lies on the unit circle, or where it is. And on the unit circle for this here, so if we're looking at 105 degrees, we're in the second quadrant, because that's going to be between 90 and 180. It's going to be between 90 and 180 degrees. So that tells us that cosine is going to be negative, because cosine is negative in the second quadrant. So our value for this here is going to be negative, because 105 degrees for cosine is negative in the second quadrant. Unfortunately for us, 105 degrees is not on the unit circle. Now we can double that. We can multiply 105 by 2 and get 210 degrees and see if it is on the unit circle. And 210 degrees is on the unit circle, so we can use the half-angle formula. Because cosine of 210 divided by 2 is going to be the same as cosine of 105, because 210 divided by 2 is 105. So really what we're looking at for this formula is negative square root of 1 plus cosine of 210 degrees, all divided by 2, or just divided by 2. Negative square root over 2. Now at this point here, we can use the unit circle to see what cosine of 210 degrees is. And that's going to be negative square root 3 over 2. Okay. Any questions on this so far? Now, okay. At this point here, we could go through and simplify this by hand, or we can plug everything that's inside the square root into the yellow calculator. The TI-30XS should and will simplify that for us. Okay. Now, if we did this by hand, the first thing we're doing is this here, 1 minus the square root 3 over 2. Now this here is really just saying that we're taking square root of 1 minus the square root 3 over 2, and we're dividing it by 2. And especially since we do have a fraction, really, we need to change it from division to multiplication and flip the second term, which at this point we can multiply through, which will give us 1/2 minus square root 3 over 4. Now for us to be able to combine like terms here to make it one fraction, we do need to change 1/2 so that the denominators are the same, which is really making this into 2/4, which is going to give us 2 minus the square root of 3 over 4. Because 1/2 is going to be the same as 2/4. At this point here, we'll be taking the square root of the numerator and denominator. So the numerator is going to be the square root of 2 minus the square root of 3. And the square root of 4 is, well, 2. And we get this here. And the calculator would have, the 30xs would have given you the negative square root of 3 minus 2 over 4, which we can then simplify from there. Questions on any of this here? Not too bad, just a lot of manipulating, yes? Okay. All right. The next two parts are going to be solving, so we want to find all the solutions of this here. So we have 1 plus cosine squared is equal to 2 cosine squared of x over 2. 2 cosine squared of x over 2. Well, one of the things that we definitely need to do is to, 1, get rid of this x over 2. Because we need all the sine, cosine, tangent. We need them in terms of x or all in x over 2. We need them to have the same thing inside the parentheses. Now, what we do know is that cosine of x over 2 is equal to plus or minus the square root of 1 plus cosine of x all over 2. So the first thing we can do is apply this formula here. So I can replace cosine with our plus or minus the square root of 1 plus cosine of x over 2. So here the first thing we did is just took the half angle formula and plugged it in. Any questions on this so far? Now what's interesting with this here is that the square is when we square a positive number, if that square root is positive, well, positive times a positive is a positive. If it was negative, a negative times a negative is a positive. So this square and the square root do cancel out, but it also simplifies out the plus or minus 2, which is kind of convenient. Because over here we still have 1 plus cosine squared of x is equal to 2 times 1 plus cosine of x all over 2. Well, actually the 2 and 2 will cancel out, leaving us with 1 plus cosine squared of x is equal to 1 plus cosine of x. Questions on this here so far? Now at this point here we can get this equal to 0. So we could subtract 1 from both sides, and we can also subtract cosine of x from both sides so that we get this equal to 0. We're here, 1 minus 1, that's going to be 0 on both sides. So we'll still have cosine squared of x. And we'll also have minus cosine of x is equal to 0. Now there's different ways we can go about solving it from here. But the way I would look at it is that we do have a cosine in common with both of these here. So we can factor it out. Which tells us that cosine of x times cosine of x minus 1 is equal to 0. So because we have two things multiplied together to equal 0, one of them must be 0. Now cosine of x equals 0. That tells us x is equal to pi over 2. Or we could also have that x is going to be 3 pi over 2. Does it ask for all the solutions? We have to add the 2 pi in. But again, since these are 1 unit, or essentially pi units away from each other, we could just rewrite it as pi over 2 plus pi n instead of writing it as two statements. And on the other side, cosine of x minus 1 equals 0 is really just saying that we have cosine of x is equal to 1. Well, cosine of x equals 1 at 0 degrees. And since we aren't restricted on the interval from 0 to 2 pi, we can say x is equal to 0 plus 2 pi. Or really, this is just saying that x is equal to 2 pi n. Any questions on this here? So between 0 and 2 pi, or 0 and 6.28, we have 1, 2, 3 solutions. If we wanted to look at this on the graphing calculator, we can. Because we can say 1 plus cosine of x squared minus 2 cosine alpha y equals enter x over 2 close parentheses squared, hit graph. So between 0 and 6.28, or we can say second calculate value 2 pi, we can see that, well, 2 pi is a solution, 0 is a solution, and it does intersect at 2 other points. So we have all of our values. Questions on any of this here? Are you ready for the next one? So the next one we're looking at is cosine squared of x. I'm just going to subtract over sine of x over 2, decimal 2, parentheses squared. Second trace, enter 2 pi. So if we look at this here, it does intersect the x-axis at 1, 2, 3 different locations. So we're looking for 3 different solutions, possibly plus 2 pi n, or it could be the case that one of them does repeat pi units. But we're looking for at least 3 specific solutions. Now, 2 things. One, we need to get this in terms of cosine. And 2, it would be nice to get rid of the half angle. But luckily for us, sine of x over 2's formula is going to be plus or minus the square root of 1. Let's see here, make sure it's minus cosine of x all over 2 squared. So we replace sine of x over 2 with its formula, plus or minus the square root of 1 minus cosine of x over 2. Questions on this so far? Well, luckily for us, all of this and the plus and minus will cancel out with the square root of 2. Really just telling us that cosine squared of x is equal to 1 minus cosine of x over 2. Well, what can we do next? I know my gut instinct is to get rid of fractions. If we can get rid of fractions, I will. Now, this works with most any type of higher degree polynomial that you're solving. If you encounter fractions, decimals, anything like that that you want to get rid of, it's easy to do. Because we can multiply by a scalar. Because I can multiply this entire function by 2. If we had multiple fractions in a polynomial equation, we can multiply by whatever the denominator, whatever is going to make the denominators go away. So if all the denominators were 2 and 3, we can multiply by 6 and it'll simplify it out. It won't change the solutions, but it'll change everything else. It'll change how it looks. So what that'll give us is 2 cosine squared of x is equal to, well, those cancel, 1 minus cosine of x. Now we do need to get everything onto the same side of the equation. So we'll need to add cosine of x to both sides and subtract 1. Which will tell us that we have plus cosine of x minus 1 is equal to 0. Now at this point here, we could use the quadratic formula. The quadratic formula would work just fine, or we can factor. And if we factor it, because I think factoring, if it factors, it works a little bit faster than doing the quadratic formula, is look for greatest common factors, which there aren't any. Then we look at the signs. Since the third term is negative, our signs are opposite. Our factors of 1 are, well, 1 and 1. We will need cosine of x. It's both of them. Now we need to determine where we're going to put the 2, factors of 2. Because factors of 2 are 1 and 2, so we'll either need to put, well, one of them will have 1, which will just keep it as cosine of x, but one of them is going to get a 2. Now we know the middle term is positive, yes? So we'll need the 2 to multiply with the positive 1, which means it's going to go over here. And we can check it here too, or cosine of x times negative 1 is going to be negative cosine of x, plus 2 cosine of x, which gives us a positive cosine of x, which we wanted. Questions on this here? Okay. Specifically, that tells us that cosine of x plus 1 is equal to 0, and that 2 cosine of x minus 1 is equal to 0. So for the first one here, we have that cosine of x is equal to negative 1, because we had to subtract 1 from both sides. which gives us this here. Now for us, cosine of x equals -1 at pi. Now because they didn't give us a restriction on what this is, we do have to add 2 pi in to it. Now it'd be very tempting to try to rewrite this, but I can't just write it as pi in or 2 pi in, because 2 pi in would get us at 0, it'd get us the other side. It would be a +1. I can't write it as pi in, because pi in would work half the time, because 1 would get us over to pi in, but 2 would put us at 2 pi, which is not the right answer. So unfortunately, that's as simplified as that one gets. Now on the other side, we'll need to add 1, telling us 2 cosine of x is equal to 1. And when we divide by 2, it'll tell us cosine of x is equal to 1/2. Now there's 2 places where cosine of x is equal to pi over 3. Or not, pi over 3 is 1/2, and that's when x is pi over 3 or 7 pi over 3. And again, because they didn't restrict the domain, we have to add 2 pi in to it. Questions on any of this here? Questions on anything we've done so far? Not too bad. All right, let's look at the next problem. Rewrite the product, cosine of 5x, sine of 4x as a sum or difference. So again, reference sheet. Up in the top corner on the first page, we do have product to sum formulas. And if we look at the product to sum that they gave us, is we have cosine times sine. Now, it seems very interesting because we do have cosine times sine and sine times cosine, because there's 2 of them, but it's not going to make a huge difference on which one we pick, as long as you put u and v correctly. So we could say that this here is 1/2 of sine of u plus v minus sine of u minus v. And for us here, the u is 5x and v is 4x. So here we'd have sine of 5x plus 4x minus sine of 5x minus 4x. Five x plus 4x is 9x. 5x minus 4x is x. That's it. I mean, if we wanted to, we could take it a step further and say 1/2 sine of 9x minus sine 1/2 sine of x. I don't think that's any simpler, any different. It's the same thing. But that's it. Questions on this here? Okay. I think those are fine. I don't think you'll need to see another example of essentially just plugging it into the formula and simplifying. Now this one here is essentially the exact same thing. Find the exact value. Well, sine of 195 degrees we don't have, or cosine of 195 and cosine of 105 we don't have. But if we look at the product to sum formula, So cosine, let's see here. I see what we're doing. Now, here, we do have two cosines, yes? Now, the formula, whenever we have cosine and cosine, and they're being added together, minus on both cases, doesn't seem right. Yeah. That's what I thought. Cosine of A, cosine of B should be plus. So cosine of U, cosine of V should be plus. So here, cosine of U, cosine of V should equal 1/2 of cosine of the rest of the triangle. Cosine of A plus, so cosine of U plus V plus cosine of U minus V. Is the formula that we have. Now we can multiply both sides by 2, telling us that 2 cosine of U cosine of V is equal to cosine of U plus V plus cosine of U minus V. Okay. Now it might seem weird how this relates, but what we're saying is that 195 is U plus V. Cosine of 105 is U minus V. So what we have is that U plus V is equal to 195. U minus V is equal to 105. So we have two equations, we have a system, and we need to solve. Now there's multiple ways we can do this. One of them is using the matrices, because we could type it in as a matrix as 1, 1, 195, the second row 1, -1, 105. Use our RREF, reduced row epsilon form, to get there. Or we can use elimination. I can add these together. And if we add these together, well, U plus U is 2U. V plus negative V is 0. And if we add 195 and 105, we get 300. Divide both sides by 2, and it tells us that U is 150. What would V have to be? 195 minus 150 is 45. Any questions on this here? So we do have what this is now with U and V, and it's equal to cosine of 150 times cosine of 45. Luckily enough, cosine of 150 degrees is on the unit circle. It is negative square root 3 over 2. And cosine of 45 is also on the unit circle. It is square root 2 over 2. So at this point here, we just have to multiply these together. Now in the numerator, it's going to be negative because square root of 3 times square root of 2 is the square root of 6, yes? Well, I can say one of those cancels out with one of those, yes? Which leaves us with negative square root of 6 over 2. Huh? It just gave you that? Yeah. And that's, again, one of the nice things about these calculators. We've gotten to a point where they can do all of this for us nicely. So, yeah, the calculator will do all of these. The only ones that are a little bit different are the half angle formulas, because it's going to, instead of using the half angle formula, it'll use this angle sum or difference formula to get there. I think we feel good with this here, yes? For the most part anyways.